Welcome to the demo for lesson 28 for college algebra. How do we identify a linear function versus an exponential function if you're looking at a table of data? So this table represents values from one linear function and one exponential function, and we want to figure out which is which. So we're going to look at the delta x, the change in x for each of these functions. So for f, my delta x, my x for all of them, my delta x, 20, 25, 30, 35, 40, 45, my delta x is always 5. All right, now I want to look at my differences, which is again subtraction, right? The differences in my values for f. So for f, I have 30, 40, 50, 60, 70, 80. My change in f is always 10, right? So the differences between consecutive values of f of x is always 10. But for g of x, the differences between consecutive values is not always the same. So let's actually look at them. 1300 minus 1000 is 300. But then if I do the next one, 1690 minus 1300, that is 390, right? So my delta, my change in y for the g value is already not constant. And you can keep checking them if you want. So these are not constant. These are always 10, or constant, meaning not changing, always 10. But g of x does have a common ratio. If you actually divide the values, 1300 over 1000 is 1.3. 1690 over 1300 is 1.3. So we get a common ratio, a constant ratio between values of g. So f, when you have a constant difference, this is linear. When you have a constant ratio, this is exponential. So if you're looking at formulas, p of t equals 1000 plus 1500 t, we say this is a linear function because it is additive. For each year that passes, we add 1500 to the number of rabbits, thinking about the rabbit population from the preview exercises. If p of t is 1000 times 2 to the t, this is exponential because it's multiplicative. That means for each year that passes, you multiply the number of rabbits by 2. Generally speaking, a linear function is written as output equals initial quantity plus rate of growth or decline times the input. In terms that you're more used to seeing, you might say y equals initial quantity b plus mx. Rate of growth or decline is your slope times your input x. For an exponential function, your output is going to be your initial quantity times your growth or decay factor to the input. Using symbols, this would be y equals a times b to the x. In conclusion, we say linear functions represent quantities to which a constant amount is added or subtracted for each unit increase in the input, whereas exponential functions represent quantities that are multiplied by a constant factor for each unit increase in the input.